question at hand involves the National Electrical Code, specifically concerning the use of a 200 amp main breaker in a 42 circuit panel, especially in the context of a transformer feeding an 800 amp current transformer cabinet and then dispersing 200 amps to 4 separately metered tenants. The core issue revolves around whether eliminating fuse disconnects between the meters and installing 42 circuit panels with 200 amp main breakers is code compliant. It is essential to understand the relevant sections of the National Electrical Code to make an informed decision. Let's break down the applicable code sections and their implications. According to the 2002 National Electrical Code, Section 230.90 Exception 2, the design approach of using a 200 amp main breaker in a 42 circuit panel could indeed be code compliant under certain circumstances. This exception states that where the branch circuit panel board is the service equipment, the rating of the main circuit breaker or main fuse shall not exceed that permitted by Section 230.40 for services. In the described scenario, the transformer feeding the current transformer cabinet is considered the service equipment, and the 800 amp current transformer cabinet acts as the service disconnect. Therefore, according to this interpretation of the 2002 National Electrical Code, the main breaker in each of the 42 circuit panels can be rated up to 200 amps. This stems from the allowance that the panel is effectively part of the service equipment downstream of the main service disconnect. However, it is crucial to recognize that the National Electrical Code undergoes revisions periodically and different editions have different requirements. The 2005 National Electrical Code and subsequent editions introduce changes that impact the application of these rules. Specifically, in the 2005 National Electrical Code, the main circuit breaker or main fuse in service equipment must be rated not greater than the ampacity of the service conductors. This means that if the scenario falls under the 2005 National Electrical Code or later editions, the main breaker in each of the 42 circuit panels may need to be rated higher, potentially at 800 amps, to match the service conductors feeding the current transformer cabinet. To further clarify, let's consider a practical application of these code sections. Imagine a building in Pennsylvania where the electrical system is designed based on the 2002 National Electrical Code. In this case, installing 200 amp main breakers in the 42 circuit panels for each tenant would likely be compliant, given the conditions outlined earlier. However, if the same building were to be designed or upgraded under the 2005 National Electrical Code or a more recent edition, adhering to stricter requirements for service equipment would necessitate a different approach. One must consider the specific language of the code edition in effect to ensure compliance. It's also important to delve into the concept of service equipment as defined by the National Electrical Code. Service equipment includes the main disconnect, of a current protection, and any other equipment intended to constitute the main control and cutoff means for the supply. The location and arrangement of these components significantly influence how the code is applied. In the context of the original question, the 800 amp current transformer cabinet serves as the service disconnect. Therefore, any panel boards downstream must adhere to the rules governing equipment connected to the service. The National Electrical Code provides guidance on sizing conductors and overcurrent protection devices based on the load they are intended to serve. For instance, Section 220 covers branch circuit, feeder, and service calculations. Accurately calculating the load is crucial to ensuring that the selected components are appropriately sized and protected. In the given scenario, each tenant is allocated 200 amps. The main breakers in their respective panels must be capable of handling the anticipated load while also complying with the overcurrent protection requirements outlined in the National Electrical Code. The decision to eliminate fuse disconnects and replace them with main breakers in the panel boards requires careful consideration of the code and the specific requirements for overcurrent protection. The National Electrical Code outlines various methods for providing overcurrent protection, and the chosen method must align with the overall design and safety considerations. Moreover, the physical installation of the electrical equipment must comply with the National Electrical Code's requirements for clearances, accessibility, and environmental protection. The National Electrical Code specifies minimum working clearances around electrical equipment to ensure that electricians and other qualified personnel can safely install, maintain, and operate the equipment. These clearances vary depending on the voltage and configuration of the equipment. Additionally, the equipment must be installed in a location that is accessible for maintenance and protected from environmental factors such as moisture, corrosion, and physical damage. The type of wiring method used, such as conduit, cable, or busway, must also comply with the National Electrical Code. Each wiring method has specific requirements for installation, support, and protection. For example, conduit must be properly supported and grounded, while cables must be protected from physical damage. Furthermore, the selection of conductors must align with the ampacity requirements outlined in the National Electrical Code. The ampacity of a conductor is its current carrying capacity, and it depends on factors such as the conductor material, size, insulation type, and ambient temperature. The National Electrical Code provides tables that list the ampacities of various conductors under different conditions. It's essential to consult these tables to ensure that the selected conductors are capable of handling the anticipated load. Grounding and bonding are critical aspects of electrical safety, and the National Electrical Code dedicates several sections to these topics. Grounding provides a low impedance path for fault current to return to the source, while bonding ensures that all metallic parts of the electrical system are electrically connected. Proper grounding and bonding help to minimize the risk of electric shock and fire. The National Electrical Code outlines specific requirements for grounding electrodes, grounding conductors, and bonding jumpers. These requirements vary depending on the type of electrical system and the size of the conductors. Additionally, the National Electrical Code addresses the use of surge protection devices to protect sensitive electronic equipment from voltage surges caused by lightning or other transient events. Surge protection devices are typically installed at the service entrance and at individual branch circuits to provide comprehensive protection. The National Electrical Code specifies the types of surge protection devices that are permitted and the requirements for their installation. Coordination of overcurrent protection devices is another crucial aspect of electrical system design. Coordination ensures that the overcurrent protection devices closest to the fault will operate first, minimizing the extent of the outage and preventing damage to the electrical system. The National Electrical Code provides guidance on coordinating overcurrent protection devices, including the use of time current curves and selective coordination studies. In addition to the technical requirements, the National Electrical Code also addresses administrative aspects such as permitting, inspection, and testing. Electrical installations must typically be inspected by a qualified electrical inspector to ensure that they comply with the National Electrical Code and other applicable regulations. The National Electrical Code also requires that electrical equipment be tested and certified by a recognized testing laboratory to ensure that it meets safety standards. Understanding and applying the National Electrical Code requires ongoing education and training. The National Electrical Code is updated every 3 years, and it's essential to stay current with the latest changes. There are numerous resources available to help electrical professionals stay informed about the National Electrical Code, including training courses, seminars, and online resources. Moreover, the National Electrical Code provides specific requirements for different types of electrical systems, such as residential, commercial, and industrial systems. Each type of system has unique characteristics and requirements, and the National Electrical Code addresses these differences. For example, the National Electrical Code has specific requirements for the installation of ground fault circuit interrupters in residential bathrooms and kitchens. These devices protect against electric shock by detecting small leakage currents and interrupting the circuit. The National Electrical Code also addresses the use of arc fault circuit interrupters in residential bedrooms. These devices protect against fires caused by arcing faults in electrical wiring. Furthermore, the National Electrical Code provides guidance on the installation of renewable energy systems such as solar photovoltaic systems and wind turbines. These systems require special considerations for grounding, overcurrent protection, and disconnecting means. The National Electrical Code also addresses the storage of batteries used in renewable energy systems. In conclusion, when considering whether to eliminate fuse disconnects and use 200 amp main breakers in 42 circuit panels, you must first determine which edition of the National Electrical Code applies to the project. The 2002 National Electrical Code provides more leniency in this regard, while the 2005 National Electrical Code and subsequent editions impose stricter requirements for service equipment. Careful consideration of the applicable code edition, the definition of service equipment, the load calculations, and the overcurrent protection requirements is essential to ensure code compliance and electrical safety. Remember that this information is provided for educational purposes and should not be considered a substitute for professional engineering advice. Always consult with a qualified electrical engineer or licensed electrician to ensure that your electrical designs and installations comply with all applicable codes and regulations. Firstly, it is important to consult the specific edition of the National Electrical Code enforced by the local jurisdiction. Secondly, thoroughly analyze the electrical load calculations for each tenant to ensure that the 200 amp main breakers are adequately sized. Thirdly, verify the electrical equipment is properly grounded and bonded according to the National Electrical Code requirements. Fourthly, coordinate the overcurrent protection devices to minimize the extent of any potential outages. Fifthly, ensure that the electrical installation is inspected and approved by a qualified electrical inspector. By following these steps, you can help to ensure that your electrical designs and installations are safe, reliable, and code compliant.